Hello students, welcome to the session on ventilation and air conditioning. I am Mr. Manoj H. Mutap, Assistant Professor, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering. So ventilation may be defined as supply of fresh outside air into an enclosed space or the removal of inside air from the enclosed space. This is the major component which deals with the comfort levels of the occupants or users. So why we need to ventilate a space? We need to ventilate a space for the creation of free air movement, prevention of undue accumulation of carbon dioxide which has been exhaled by the users, prevention of flammable concentration of gas vapors from the locations like kitchen, prevention of accumulation of dust and bacteria carrying particles, prevention of odor caused by decomposition of building material, removal of smoke, odor and foul smell generated or liberated by the occupants, removal of body heat generated or liberated by the occupants, prevention of condensation or deposition of moisture on wall surface, and prevention of suffocation conditions in various large rooms like conference rooms, committee halls, cinema halls, big rooms, etc. So this is a table which tells us about the different classification of climate. These are recommendations from National Building Code of India according to clause 3.2.1, which divides the zones of India into different climatic zones like hot, dry, warm, humid, temperate and cold. So the mean monthly temperature and mean monthly relative humidity conditions have been given. These are the conditions which generally divides the climate into various zones. This is a recommended value for air change per hour. The meaning of air change per hour means we need to change the air up to these many times per hour. For example, in case of assembly rooms, the recommended value of air change per hour is 4 to 8. Means the assembly room has, say, suppose a volume equals to x meter cube. Then we need to change its air at least 4 to 8 times the x meter cube so that the effective ventilation can be achieved. These values are different for different rooms and we need to follow these conditions for the effective ventilation as such. Systems of ventilations. The system of ventilation may be divided into two categories. One is natural ventilation and second is artificial or mechanical ventilation. So natural ventilation is one in which ventilation is effected by the elaborated use of different openings like doors, windows, ventilators and skylights. It is usually considered suitable for buildings and small houses. However, it is not useful for large buildings, offices, halls, auditoriums and large factories where the volume is very large and comparatively the openings are smaller and the expected amount of air change may not be achieved just by keeping the opening and expecting those amount of air to be exchanged just by the natural forces. In natural ventilation, cross ventilation normally relied to secure air movement. It is economical since no equipment is required for keeping the room ventilated. In natural ventilation, the rate of ventilation depends on two effects. One is wind effect and second is stack effect. Wind effect. In this, the rate of ventilation depends upon the direction and velocity of wind outside and size and position of openings. Such an effect is known as ventilation due to wind action. In designing a system of natural ventilation, the aim should be to make effective use of wind forces. Ventilation due to stack effect. In this, the rate of ventilation is affected by convection effect arising from temperature or vapor pressure difference or both between inside and outside of the room and the difference in the height between the outlet and inlet openings. When air temperature inside is higher than the outside, warmer air rises and passes through the openings located at the upper part of the room, whereas incoming cool air enters from the lower opening. This is the major principle used in this type of natural ventilation. Ventilation due to both effects. When both wind and stack pressure are acting, it is proper to calculate each pressure acting independently under conditions ideal to it and then apply a percentage. However, a ventilation in residential building due to stack pressure both in hot arid region and in hot humid region appears to be insignificant and at any rate may be neglected, as when both wind pressure and stack pressure are acting, the wind pressure effect may be assumed to be predominant. Next is mechanical or artificial ventilation. It involves the use of some mechanical equipment for the effective air circulation. It is provided in those circumstances where satisfactory standards of ventilation in respect of air quality of controllability cannot be obtained by natural means. This system is costly, but it is resulting in considerable increase in the efficiency of person. There are following systems of artificial ventilation. First is extraction system, second is plenum system, then the combination of these two, extraction plenum system and the air conditioning. In extraction system, which is even called as an exhaust system, is based on creation of vacuum in room by exhausting the stagnant or inside air by means of propeller type fans, which are popularly known as exhaust fans. Air inlets are formed at a height of 1.2 to 1.8 meter through the different tubes or through windows, and the outlet is arranged within a quarter of meter of the ceiling on the opposite side of the room from which air enters. Plenum system or supply system. In this system, fresh air is forced into the room and the inside air is allowed to leave through ventilators. The air inlet is selected on that side of building where the purest air is available for most of the times. The incoming air, which is mechanically forced into the room, is passed through a fine gauge screen or filter. In winter, the air may be forced through a battery of hot water tubes and be heated before being forced into the room. In case of big halls or factories, the distribution of this air is done through properly formed sheet iron ducts with properly dimensioned branches. This ventilation system is costly and is used for factories, conferences halls, theaters, big offices, etc. Extraction plenum system. This is an extension of plenum system in which extraction fans are used for the exit of the vitiated air from the room. This system is adopted where the delivery of fresh air is either sluggish or where it is desired to discharge the vitiated air conditioning obnoxious fumes as from kitchen, latrine or various manufacturing process in specially isolated areas. Air conditioning. Air conditioning may be defined as the process of treating air so as to control simultaneously its temperature, humidity, purity and distribution to meet the requirement of the conditioned space. This is the best system of artificial ventilation in which provision is made for filtration, heating or cooling, humidifying or dehumidifying, etc., thus creating the most comfortable working conditions. Necessity or purpose. In residential buildings, it is required to preserve and maintain the health, comfort and convenience of the occupants. In case of industries, air conditioning may be required to preserve the quality of industrial product and to create control and maintain the working of different processes such as artificial silk, cotton cloths, etc. Classification. From the functional point of view, the air conditioning is classified under two types. One is comfort air conditioning and second is industrial air conditioning. Comfort air conditioning. Such conditions of the air inside the room are created as would give maximum human comfort. While industrial air conditioning, such atmospheric conditions are created, controlled and maintained as would suit best to the need of industry during the material processing, manufacturing and storage, etc. Components of air conditioning system. The following are the essentials of an air conditioning system. The air conditioning systems are having filtration, heating system, which are essential for supplying air at higher temperature. Those are essential in winter season. Then cooling system, which are more essential in summer season. Humidification and dehumidification as per the need, and the air circulation or distribution. This figure indicates the air conditioner used in summer, where we need to cool the air and we need to humidify it. So such system consists of the air filters, then the cooling coil, then humidifier, and the properly designed exit as such. They are also connected with certain pumps and makeup water systems which are there for the humidification. This figure indicates the winter air conditioning. This system consists of the air filter followed by heating coil, unlike the system used in summer air conditioning. Then once again, as per need, we can humidify it or dehumidify it. Then this is connected with the second heating coil, and then it is connected with the space to be conditioned or the ducts through which the conditioned air can be circulated. Systems of air conditioning. Depending upon the location of air conditioning equipments, the systems are classified as central system, self-contained or unit system, semi-contained or unitary central system, and combined system. The major principles involved in air conditioning are that it sucks the air through the filtering media, then it cools in case of summer or heat it in case of winter, then it dehumidify if it is to be cooled or humidify if it is to be heated, forcing it into the room for proper circulation through grills, and finally the used air is collected through exhaust and mixed with some outside fresh air and sucked again through the filtering medium, thus completing the cycle. So thank you for attending this session. Thank you.